Hi everyone, in this video we'll be going over how many ways we can arrange things in a linear or circular manner. This is also sometimes called permutation. So let's say that we have to arrange, say, something like A, B, C. How many ways could we switch these elements around? Well, we would have to list them out, right? A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. So there's 6 total possibilities. However, if we just list them out like this, what will we do if it becomes A, B, C, D, E, or there's 6 elements, A, B, C, D, E, F? The problem is that if we're listing, it's going to take us ages, and it's very easy to screw it up, especially since in competitions there's a very short amount of time and you're under a lot of time and pressure. So the formula for linear arrangements is actually you count the number of elements in the set, which is 5 in this scenario and 6 in this scenario. Let's consider 5 for now. So the formula is actually just the number of elements in the set factorial. So in this situation, it would actually be 5 factorial ways, which is 120 ways to arrange A, B, C, D, E. In this scenario, there's 3, which is why it's 3 factorial, which is equal to 6. So this works with anything. One exception is that what if there are repeats? For example, what if you have A, B, C, D? If we switch these two around, it's going to be exactly the same. So it wouldn't count as another arrangement. So what we actually have to do is do the same thing, count the number of elements in the set, which is 5 factorial, but we would also have to count that there's a repeat here, and there's two of the same one, so you would have to put 2 factorial here. And your answer would actually be 60 ways to arrange it. One other thing is if there's, well, for 3, for example, A, B, C, you would actually, the answer would be 5 factorial over 3 factorial. Now, the only other thing is if there's more than one. Let's say there's A, B, B, D. It's the same thing, 5 factorial over, there's 2 repeats here, so 2 factorial, but we have to do it again since there's another 2 repeats. So you would end up with 30 possible ways. So this works for any amount of arrangements. If this becomes A, B, B, C, C, it would just be bigger. It just always follows the same method. So if there are repeats, the number of repeats goes in a factorial down here, and the number of total elements is always at the top. Now, let's take into account circular permutations. So for circular permutations, we'll only be going into how to do without any repeats, because it gets quite complicated and you will most likely not need to know it in any competitions for middle school or high school. So let's take how many ways can we arrange A, B, C, D in a circle. So the problem with a circle is if we arrange it like this, C, D, it's actually exactly the same as arranging it like this, because we can rotate this one 90 degrees to get this one. So there are less ways to arrange in a circle. So the formula for arranging in a circle is you count the number of elements in the set, which is n, and you take -1 and you do factorial. So in this case, the number of total ways to arrange in a circle would be 4 minus 1 factorial, which is 3 factorial equals 6. So this works for any type of circle, and any number of elements in a circle. So if this was 5, it would be 4 factorial. If this was 6, it would be 5 factorial. Always just remember, in a circle, it's always -1 of the number of elements in the set. So, just to recap, for linear arrangements, you take the number of elements in the set and you factorial it. If there are any repeats, let's say you have 2 repeats of R, of A, then you would put 2 factorial. If there's another 3 repeats of C, that would be 3 factorial. Always remember repeats go down here, and the number of repeats there are is the number that goes in front of the factorial. And these are multiplied. So number of circular arrangements, always just count the number of elements in the set, take one off, and then factorial it. All right, this was pi squared and how to figure out linear and circular arrangements. Thank you.